Hi everybody, it's your boy Dr. Naz here. In exercise 15D, we're going to be talking about the area of a triangle. So obviously we're pretty familiar with the idea that a triangle, or the area for the formula of a triangle, is a half of the base times the height. However, there's another representation for the area of a triangle, and the idea is that if you kind of have a look at this right angle triangle here, okay, this right angle triangle, so the base is B of this triangle and the height is H. But if you think about it, H can also be written as C times sine of A. Okay, so instead of writing a half BH, you can write it as a half BC sine A. And one of the key things you have to note here is that BC and capital A, in the way they're related, is the idea that the angle is between the two sides. And then you got your two sides, okay? So if you want to apply this formula, you have to make sure you're choosing an angle, a given angle between two given sides, all right? So let's have a look at a couple of these examples. Example 1, we've got find the area of the triangle. This one's a direct application of the formula because if you have a look, you have your two sides, okay? And then you have your angle that's between those two sides, okay? So your area would just be equal to a half BC sine of A. So in this case, this is B, this is C, and this is A, okay? So you end up with 1/2 of B, which is 8, C, which is 12, and then you got sine of 70 degrees, okay? And just get my calculator. So 8 times 12 is, was it 96 divided by 2? We end up with 48. So we end up with 48 sine of 70 degrees. And then I'll just put that in my calculator once it decides to load. Give me 1 second. All right, so we got 48 times sine of 70. All right. Sorry, guys, 1 second. All right, so the answer that I got was 45.1 units squared. So in this case, it's centimeters squared. Okay, I didn't actually have my calculator set up on degrees, which is why I had to do a conversion. So I might just fix that really quickly. So settings, document settings, instead of radians, we'll go degrees. Just easier to input directly for these questions. All right, let's have a look at the second one. So the second one is find the area of the triangle. We want to use a half BC sine A. However, we're not actually given any angles. But remember we learnt the sine and the cosine formula, which should help us find an angle. So let's say, for example, remember with the cosine formula, I talked about the arrow. So let's say, for example, we set up an arrow like this. Okay, like that. So can you see how the two sides of the arrow are on the 14 and the 13, and then the main part of the arrow is on the 7, which means the angle we're going to find by applying cosine rule here would be that capital A, that small angle there, okay? So we know that normally we got A squared equals B squared plus C squared minus 2BC cos of A, which if you rearrange, you get that cos of A is equal to B squared plus C squared minus A squared over 2BC. And the only thing you need to kind of be aware of here is little a is the one that's opposite to capital A. It doesn't really matter what you call B and C in this case. So I'll call this one A, I'll call this one B, and I'll call this one C. And we end up with 14 squared plus 13 squared minus 7 squared divided by 2 times 14 times 13. And then obviously whatever you get, it's just inverse cos of that. So let's just put in directly into our calculator that A equals inverse cos of this entry over here. So if I just go trig inverse cos, and I'm going to put in those values. So we get 14 squared plus 13 squared minus 7 squared all didn't do that right. 1 second. Just fixing up my brackets. 1 second. Okay, I think that'll fix the problem. All divided by 2 times 14 times 13, which is equal to 29.7577. So I'm just going to write 29.76 to kind of round, okay? And then once you're given the angle, the area, okay, so the area part's on the right side here, the area is 1/2 times BC sine A. So in our case, 1413 times sine of the angle we just found. So 1/2 times 14 times 13 times sine of 29.76 degrees. And I'm going to make sure I grab the value directly from my calculator rather than rounding, so we don't lose accuracy. So 0.5 times 14 times 13 times sine of that value. Okay, we end up getting 45.17 centimeters. Centimeters squared. Okay. And now question 3, find the area of the triangle below. There's a couple of ways you can do this. The way I'm going to do it, because we need to find an extra side length. That's our issue over here. The way I'm going to do it is I'm going to use interior angles of a triangle. So I'm going to call this one alpha. So we know just starting off that alpha is equal to 180 minus bracket 85 plus 37. The thing in the brackets is just equal to 112, which gives you, what does it give you? 68 degrees, okay? So when our alpha is 68 degrees, and the reason I wanted to find that is because I'm going to use that to find the side length of one of these sides. So if I go now and I go, I want to remember for the sine rule, we're going to use the propeller. So I'm going to do that and I'm going to do that, okay? So we already have that kind of side angle pairing on one of them, and we want to use the sine rule to get the other side angle pairing. So what we're interested in is this side over here, which is x meters, okay? So sine rule tells us that x divided by sine of alpha, which is 68 degrees, is equal to 21 divided by sine of 85 degrees. So which tells you that x is equal to 21 times sine of 68 degrees divided by sine of 85 degrees, okay? And you put that into your calculator. So 21 times sine of 68 divided by, divided by sine of 85. You end up with, tell you in a second, 19.55 rounded, okay? So 19.55 meters, okay? And now the idea is that, again, I'm going to apply the area of a triangle formula, but I want to grab the x value from the calculator rather than from the rounded value we've just put, okay? So the area from here would be equal to, I've got to be a little bit careful. So on the previous question, I wrote A and then I wrote A again, okay? What I actually mean by this A over here is the area. And what I mean by the A that I've highlighted over here, this is the angle A, okay? So that was my bad. I'm going to write area instead for this time. So we have 1/2 BC sine of A, okay? So just put in your pronumerals. So in this case, I'm going to use the 21, the x, and the 37. Remember, it has to be the angle that's formed by the two sides you know. So it's 1/2, 21, x, which is 19.55, times sine of 37 degrees. And then put it into your calculator. So just remember, I'm going to grab the exact value for 19.55. So 21 times 19.55, which is that ratio of sines, times sine of 37 degrees, okay? And then from there, we get an approximate area of 123 0.5 meters squared, okay? Because the unit is meters. All right, and that's it for 15D. Hopefully relatively straightforward. And thank you for tuning in.